Okay, this is a lesson about chapter 5, quadratic functions, and we have two big words here, quadratic and function. Now, before we go deep into quadratic functions, let's recall back what is a linear function. If we use the independent variable for x and dependent variable for y, and this is the function y equals 3x minus 2, this function show you the relation between the x and y, right? The relation if the value of x equals what and y equals what. And since the independent use the first degree for the x, so this is the first degree of a polynomial, and the name of it is linear. Okay, that's why it's called linear. And why is it called function? We recall back before the definition of a function, it is the relations that one value of x will give you exactly only one value of y. Okay, one value of x, exactly one value of y, but not vice versa. So we for function we accept one value of y can give more than one value of x. So if we want to find what is the relations between y and x in this function, of course, we can use the table of pair, right? And then if I'm substituting x by -2, and then I find the y and so on. And since, of course, we have many solutions and we cannot provide all of this relation of x and y in this table, since it's very, there's a lot of possibilities of values of x as if we find the domain for real numbers. So instead of showing the table of pairs, we graph it, right? So when we graph all of these pairs into the Cartesian, and we find it is a line. So the properties of these linear functions, of course, it is a line, a straight line. So all of the dots here will 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 show you the relations between the value of x and y for this equation, right? And for the linear function, we have a slope. Okay, we have one x-intercept, we have one y-intercept, and by referring these equations, of course, we get a hint that if I have a bigger value, or the x value become greater extremely to the positive side, I will also will have uh, an extreme large number for the y, right? Since it is going consistently to there. Or if this is the case, okay, if this is the line, of course I can get a hint if I have, like, for example, 1 million of x, 1 million as my x values, I will have a quite large number also for the y. So that is a linear function. So how if I have this one, this function? Okay, since we have already been deciding that the x is the independent and the y is the dependent, it means by seeing this equation, we know that the degree of the x is 2, right? There are three terms here, and this is the second degree, this is the first degree, this is 0 degree. By knowing this, we can see that the second degree name for polynomial is quadratic. That's why this is a quadratic. And let's check, is it a function? Of course, again, the requirements of a function is one value of x may only have one value of y. Okay, so how do we show the relation between y and x on this equation, on this function? So let's just using the table of pairs also. Okay, so if I use the value of x equals 0, and then so on, and I put it into this function, I will have the value of y that relates to the value of x is this on this table of pairs. And again, this is just limited values. Of course, we have to go further to use all values of real numbers for your x. This is just some of it, right? So it will take time, and the table of pairs is not the way of showing the relation between x and y in this relation. So as you can see, you will get a hint if I'm just adding -1, -2, -3. Sorry, it's for the x, and the value of y is not consistently showing direct relations linearly, right? Of course, and especially this one. If I have x equals 1, the y equals 0. If I have x equals 2, the y is 0 also. So it's obviously it's not aligned, right? And if you graph it, if you have a lot of pairs that you have searched for, and then you plot it, every quadratic function like this one we only have two possibility of shapes. The first one is this one. We call it facing downward, okay? Or this one, we call it facing upward. And this shape is called parabola. And if you can see it from these examples, uh, just just focus on these two facing downward parabola. Okay, and we can see that all of these two facing downward parabola have one y-intercept. Okay, have one y-intercept, but this one it has two x-intercepts. But this one it has one x-intercept right on the vertex. And if we go to this facing upward parabola, okay, we can see that they both have one y-intercept. And for this one, it has two x-intercepts, but this one, it has no x-intercepts. There is no intersection with the x-axis. You will get a hint that for parabola, the first they have always had a vertex. Vertex is the least or the most y value, or the highest and the lowest value of your y for your parabola. It depends on the case. If it is facing downward, the vertex is the maximum point. If it is facing upward, the vertex is the minimum point. Okay, and we will discuss this later. And if we want to discuss more about the function, since it is a quadratic functions, keep in mind that for one x, it may only have one value of y. So you can use the vertical line here to check whether, uh, to make sure that one x will have only one value of y. So in the end, you will get also a hint that this curve will never go vertically straight. Okay, so it will never go vertically straight. It will always, the x will always continue go larger and larger, and it's from this part it's growing into lesser and lesser. Okay, every, so never draw or graph your parabola with a straight vertical line. Okay, it never go that way. And let's go now to one more example. So yeah, of course, I haven't presented you the graph of this one. I'm just okay. I'm just showing you the table of pairs. But let me just show you one simple example of this quadratic function. This is not the quadratic function. Y equals half of x squared. Okay. So if I use the table of pairs, okay, sum of the x, I use 1, 2, 3, 4, 5, 6, 7, 8 value of x, and then I try to find the pair, okay, of the y. So 0, comma 0, 1, comma 0 0.5, and so on. And when I plot it, I have these dots, right? And then since I'm quite convinced that this one is the vertex, I can connect them with curve. So for this case, again, the vertex is right on this area, so it's 0, comma 0. Okay, and then um, we have only one x-intercept, the intersections is right on 0, comma 0. So for this case, we have the vertex is the same as the x-intercept. Okay, it's 0, comma 0 as the vertex, 0, comma 0 as the x-intercept, the only x-intercept. And 0, comma 0 is also the y-intercept. If we set the domain is real numbers for the x, it means it will go to, that point and go to the left infinitely, right? And it never go vertical upward, never. It's always consistently go to the left and go to the right. And one more thing about this one is that if we go to the range, okay, the range is for all value of y that comes to this graph is non-negative real, right? Zero and the positive. So there is no negative values for your y if we call back about the range and the domain. So this is another example of a parabola or quadratic function. Okay, and this is a facing upward one, and you have to know what is the terminologies of some important key points. The first one, x-intercepts. For this one, this parabola has two x-intercepts. Okay, it is the intersections with the x-axis. It has one y-intercept intersection with y-axis. It has the vertex at this coordinate. This is the vertex. Since it is facing upward, it means it is the lowest value of your y. Okay, the lowest value, the pair which has the lowest value of the y, and the vertex it will be your minimum point also for the parabola. And this one, okay, you can see that it has no name. This is the symmetric point of the y-intercept. So if you see that the vertex, if you draw a vertical line on the vertex, it will be like the mirror. So the left part will be the shadow of the right part, or vice versa. Okay, this is the mirror. Therefore, if we see the x-intercept here, the x-intercepts, so the distance between the first x-intercept with the mirror or the line of symmetry will be the same with the distance from the second x-intercept to the line of symmetry as well. So keep in mind that this is the symmetric line or line of symmetry as your mirror. So if this is your y-intercept, the symmetric point of your y-intercept will be the shadow of this y-intercept, which is this one. So this is the symmetric point of the y-intercept. If we go back to the x-intercept, it means the first x-intercept will be the symmetric point of the second x-intercept, or the second x-intercept will be the symmetric point of the first x-intercept. So for this one, if I pick this pair, the symmetric point of this pair will be this one, or this one will be the symmetric point of this one. Okay, I hope that it's clear about the symmetric point, line of symmetry, x-intercepts, y-intercept, and vertex. We only cover these terminologies, so I want you to master this. So keep in mind that every parabola will always have one y-intercept, always. Okay, so keep that in mind. But about the x-intercepts, you have to be careful. Okay, as we have already discussed before, we can have two x-intercepts, we can have one x-intercept, and we can have none x-intercepts. You can go here. This one, two, this one, none x-intercept, this one, two x-intercepts, this one x-intercept. So on the possibilities only three cases: 0, 1, or 2 x-intercepts. Okay. So let's go to the general form of the quadratic function. The general form will be this one. Okay. y equals ax squared plus bx plus c. And a is the coefficient. So this refers to a constant, the coefficient of x squared. B is the coefficient of x, and c is the constant. Okay, so in every general form, we will have a constant or a number that will replace a, b, c. So this is what we can get from this general form. First, if a, or the coefficient of the x squared, is larger than 0, which is positive, we can say it is, if a is positive, then the parabola will face upward. So for example, this one, since it is facing upward, it means the value of a must be positive. And then if the value of a is negative or less than 0, then the parabola will face downward. And the last one, the c here, is the y-intercept. Okay, since the y-intercept is the value of y when x equals 0, yes, of course, if I substitute x by 0, this will be 0, this will be 0, and only c being left. So c is the y-intercept. Therefore, well, if I give you an example, this is the equations of quadratic function, and I see that the value of a here, the coefficient of the x squared is -2, it means it is facing downward. It is facing downward, and I know that the y-intercept is 10, or the coordinate is 0, 10. Okay, so I can get these two big information just by referring to the general form. And the next form that you have to know, you must know, is the vertex form. Okay, this is the vertex form. So this is another alternation of the previous one. So if you can convert this into the vertex form, you can get the coordinate of the vertex, because the vertex coordinate will be h, k. So you need to refer to this form exactly, since you have to keep in mind this is subtraction. So it has to be in subtraction form. Okay, for example, let me give you, if I have the vertex form like this one, okay, so the a is 3. Okay, the a will be the same with this one. Okay, this is the same. Okay, so a is 3. So it means, since it is positive, this is a parabola which faces upward, right? But there is another information here that I can get. The vertex is 7, 6 h, k. And since both have subtractions, so we just can get this value. Okay, you can just extract this value. So let me just go to the second example. If I have this as my vertex form, as my equation in vertex form, and I will have the a equals -4. So since the a is negative, this parabola must face downward. And then the vertex will be 10, comma, -3. Since this is addition, of course, you need to convert into subtraction. So it will be y minus -3. Let me do this. Okay. So in the end, I will have, right? So, okay, let me just convert it back. So it will be facing downward, -4, whose vertex is 10, -3. Therefore, if I have an equation like this one, ax squared plus bx plus c, I can extract two big information here, but I cannot extract what is the vertex, right? So what is the vertex of this parabola? So how to find the vertex coordinate? One method of it will be converting this one into the vertex form. So after you convert this form into the vertex form, then I can get the H and K as my vertex. And that's what we will discuss deep further. The first skill that we need to recall is to square this x plus y. Okay, let me just remind you that x plus y square equals x plus y times x plus y. So do not answer this. So it becomes x squared plus y squared. No, you cannot distribute the square into all of this addend. So you do this, and some of you are being taught by using the square thing like this one, right? So x times x, x times y times x, y times y. In the end, you will find that it will be x squared plus yx plus xy plus y squared. Again, since this is multiplication, we can do the commutativity axiom. So x plus xy, xy, and in the end, it will be this one, right? So x plus y square will be equal to x squared plus 2x y plus y squared. Okay, so let me go to this one. And this is the I believe that you have already know this. So let's practice into this kind of situation. So x plus 4 square, it means x plus 4 times x plus 4. So if you use the square thing, it becomes x squared plus 4x plus 4x plus 16 equals x squared plus 8x plus 16. If I use this one, x minus 5 squared, so it will be equal to x minus 5 times x minus 5, and then it will be equal to x squared minus x minus 5x minus 5x, and so on. You can see in the end, it is x squared minus 10x plus 25. You can figure out there is a pattern, right? Of course, since yeah, it will be referred to this pattern. So the 8 here will be 2 times 4, right? And the 16 here will be 4 squared. And this one, negative 10, is negative 5 times 2. And this 25 is negative 5 squared. Okay. So by doing the same concept, so actually x plus 10 square will be equal to x squared plus 2 times 10 of x. So the coefficient of x will be always 2 times this. And then the constant will be 10 squared. So you have x squared plus 20x plus 100. And if I have x minus 7 square, it will be x squared plus 2 times negative 7x as the coefficient of the x, and then plus negative 7 squared. So in the end, we have x squared minus 14x plus 49. So keep in mind that the third term always positive, always. The third term always positive, but the second term, which is the coefficient of the x, it will be positive if you have addition. It will be negative if you have subtraction. Okay, so let's practice then. So x plus 7 square, okay, means you need to put the first one is x squared, and then the second one is 2 times x times 7, right? So it is 14x, and then the last term will be 49, like that. Okay, so yeah, I know you have already mastered it, but this skill is mandatory for you to master. So x plus 11 square will be x squared plus 2 times 11 times x plus 11 square. So it will be x squared plus 22x plus 121. X minus 3, x squared, and then you have this one. And the last one, yeah, keep in mind that since it's subtraction, so the subtraction only for the middle term, okay? And then the last one is still positive 9, since it is negative 3 square. Negative 3 square, negative 3 times negative 3 is positive 9. So how about this one? Of course, the last result will be the yeah, if we simplify this one, it will be x squared minus 2 times 2.5 times x. So it is minus 5x plus 2.5 square, which is 6.25. So yeah, this is the first skill that you need to master. The next one is how do we do the opposite, vice versa, is completing the square. So it is exactly the opposite of this one. So before we multiply this as we square this x minus 2.5, and this is the result. Now we do the opposite. So for example, if I give you this, and my objective is I want to factor this into a square. It is completing a square. So let me go to the first one. So if I have this x squared plus 14x plus 49 will be equal to x plus. Okay, the trick is if this is the case, you can use two methods. First, it can be this 14 divided by 2 or this 49 being square root. So it becomes 7. This will be the product of 2 times 7, and this will be the square of 7, right? So if we go further to this, the second example. So if I have this is my question. So I can figure this out by either I divide this by 2 or I square root it, but in the negative one, right? Since we have this as negative. So it is must be 6, right? Simple. Okay, so if the next question is like this, since I know that I need to fill this one, I need to complete the square. So I have this, but I'm missing the second term. So what will it be? Of course, because this is negative 5 here, it means it will be negative 5 times 2, negative 10x. Okay, and then this one, of course, since it is 30x, okay, this will be, there are two terms, there are two things that we need to fill. So the keyword here, the key point here is you know that this one will be will be exactly the same with 30 divided by 2, right? Since 30 is 2 times this one, so it will be 15. Okay, so from this viewpoint, the third term on the left member will be the square of 15, which is 125. Okay, so let's go from this one, last one. Since I know this is negative 7, it means that this one will be negative 7 divided by 2. So it is negative 3.5. Since this is negative 3.5, this one will be the square of negative 3.5, right? Which is, that means just is 12.5. Okay, so that's how you're completing the square. It means this is very important if we want to go further with the conversion from the general form into vertex form. Let me show you. The next question is how to find the vertex of this parabola. This is a quadratic function, but it's still in the general form. The a is 1, the b is 10, and the c is negative 7. But how do we find the vertex? Since from this general form, what do we know is the first thing, the shape. The shape, since it is the a is equal to 1 and it is positive, it means the parabola is facing upward. And the next one is the y-intercept. The y-intercept is 0, negative 7 from the C. So how to find the vertex? I know that some of you have already familiar with the formula, but I don't want you to use the formula now. Okay, let's practice this method first. So let's convert this form into vertex form. So let me remind you again, the vertex form is y minus k equals a times x minus h square, and the vertex will be h comma k. So let's convert this equation into the vertex form to find the vertex. So let me write down again the equation, the function. The first thing we need to know that uh, the right member contains a multiply with the multiply by a square of x minus something. Okay, So first, let's just get rid of the constant. So I add both sides by 7, okay, and then in the end, this will be the result, okay. But we already have a familiar uh, shape here on the left member. But how about right member? Well, it's still long, it's still not the same, since it is a square of something, not square of an x. It means we need to convert this into this form by completing the square. So let's complete the square on the right member. We are missing the last term. We're missing the third term. So if we want to make this into a square of like this form, it means we add something on the right member. But because we add something on the right member, we also have to add the same thing on the left member. So we add it by 25. Why? The objective is to make this as a complete square. Okay, so since we are adding both sides by 25, I will, and this will be the result of the left member. And the right member, since this will be equal to x plus 5 square, then we have the final vertex form. The a here is 1. It is not visible since, yeah, 1 multiplied by anything will be that thing. So actually it's 1, so a. So let's just uh, go to what the vertex is. So in the end, we know that the vertex will be negative 5, comma negative 32. And here's more examples about find the vertex. If we are given this equation, okay, now how to convert into the vertex, since we know that actually this is a parabola that facing upward and the y-intercept is 0, 77. So first we subtract both sides by 77, okay, and then this is the result. And then we need to make to complete the square, okay, since we know that this is negative 40. So by using that by using the method that we divide this by 2, negative 20, and then square it, we can find the last term, the last piece of the right member, which is 400, right? Since we add by 400 on the right member, which is doesn't exist before, so we have also applicate the same with the left member. So in the end, we will have this is the vertex form. Y equals, you can simplify this, and then this one is a complete square. This is equals x minus 20 square. So again, remember how to find the last piece here is by the completing the square skill. So you need to master first complete the square. Next, how to find the vertex from this equation. You can just extract 20 since these are already subtraction. It is 20. So this one is addition, therefore you need to make it negative. So negative 323. So that's your vertex. Next, if we have this is the equation. So before we have the a equals 1, now the a equals 2. Okay, now what is the impact? So we know that the a is still positive, so it must be a parabola facing upward, and the y-intercept is also the same. It's 0, 77, but the vertex must be different. So first, let's subtract both sides by 77. It's the same. So this will be the result. And please keep in mind before we complete the square, since there is a coefficient of x squared, whenever we have coefficient of the x squared not 1, we need to factor the right member first. So we have to extract 2. You factor 2, and then this is the result. Okay, since we factored 2 out, so this one will be the one inside the parenthesis. And this one is the one that we need to complete the square. Okay, so I want to complete the square of this one. So we need the last piece, the third term. How? Yeah, by dividing this by 2. So we have negative 10, and then square it. We have 100. So we add 100 inside the parenthesis. Since we add 100 inside the parentheses, we add something that didn't exist before. So we have to do the same for the left member. But keep in mind, since it is inside the parentheses and this have a coefficient, this parenthesis has a coefficient, it means you have to add the left member by 100 multiplied by 2. Okay, don't forget because there is a 2 here. So you cannot add the left member by 100 also since it's not equally the same. Remember, the right member has 2 as the factor here. So that's the real difference only. And in the end, you just simplify the left member by adding this. And then this one, you just convert into a square. So yeah, this is the result. So the A is 2 and the vertex can be extract from here and here. So it is 10 comma negative 123. Okay, so let me just give you one more example so you can get the idea. So if this is the equation, how to convert into the vertex form? First, of course, we subtract both sides by 4, right? So yeah, we subtract both sides by 4, and then we will have this as the simplified one. And don't forget, since the x has a coefficient, we need to factor negative 3 out from these two terms, right? So let's factor negative 3 out. In the end, you have negative 3 multiplied by x squared plus 5x. Now, this is the one that we need to complete the square. X squared plus 5x. How to find the last piece? The third term is by first divide 5 by 2, which is 2.5, and then square it. So it is 6.25. So since I add 6.25 on the right member, which didn't exist before, so I have to add the same value on the left member, but don't forget, since there is a factor here, negative 3, so to make the value equal, it has to be negative 3 multiplied by 6.25. So it is negative 18.75. So now we have the last step, which is simplifying the left member and then factor the right member since it is a complete square. So by this vertex form, we can find that the value of the vertex, or the coordinate of the vertex is negative 2.5, comma 22.75. Yeah, that is how you find the vertex by using a conversion into the vertex form. The main thing is you need to know the vertex form and the conversion. Regarding that, it doesn't matter if you know the formula to find the vertex, since this skill will be applied in some other concepts. So you need to master this one. So please keep practicing.